Okay, class. We continue with the second type of the mechanism of alkenes, which is the hydration. Hydration process is the process of addition of the H2O to the carbon-carbon double bond. So the type of the reaction for the hydration is the electrophilic addition, same as the hydrohalogenation. But we add the H atom and OH group to the carbon-carbon double bond. Sebab addition of H2O. H2O consists of H atom and OH group. Okay? Alright. So the name of the reaction is hydration. The type of reaction is electrophilic addition. Okay, as example, kita ada this alkene reacted with the H2O with the presence of the catalyst. Okay, remember this process of the hydration needs catalyst, which is the dilute sulfuric acid to form the product. So the product form we can predict by using the Markov-Nikov rule. Okay, kita fokus on the carbon-carbon double bond here. So which carbon will added by the hydrogen, which carbon will added by the OH group from the water. So by using the Markov-Nikov rule, each atom is added to the carbon containing higher number of hydrogen, which is in this case, the first carbon contain 2 hydrogen. Second carbon do not has any hydrogen bonded to it. That is why lah, for the formation of the product, okay, kita akan dapat CH3 single bond C, CH3 does not change sebab tak ada carbon-carbon double bond, but the carbon-carbon double bond becomes single bond. So first carbon is added by 1 hydrogen. From 2 hydrogen become 3 hydrogen here. Tengok betul-betul Okay, cara kita predict produk 2 jadi 3 lah. Because the first carbon is added by 1 hydrogen. While the second carbon here added by OH group. Itulah produk yang kita nak tunjukkan. So, ni adalah predict product based on the Markov-Nikov rule. So, as usual, soalan biasanya akan tanya pula, show the mechanism for the formation of the product. So, that's why lah pelajar dah boleh tahu dah, mechanism tu mesti dapat final product dia macam yang awak predict by using the Markov-Nikov rule. If you not get the same product based on the Markov-Nikov rule, that means your mechanism is incorrect. Okay, so mechanism for the hydration involving 3 steps. The first step is formation of the carbocation. So macam yang dia kata sebelum ni, dalam 5.1, kita nak buat step for the mechanism mesti starting with the reactant use. So kita ada reactant, alkene, air dan juga catalyst. Okay, so ketiga-tiga bahan tindak balas ini akan digunakan in the first step, iaitu kita ada alkene dan juga kita punya H2O in the presence of the acid H3O+. What is mean by the H3O+ here? H3O+ dekat sini datang daripada H2O mixed with the catalyst of the sulfuric acid. Macam awak belajar masa SEM 1 dululah. Ingat lagi tak SEM 1 dulu kita belajar macam mana? Bila acid H2SO4 react with ataupun dissociate in water, dia akan buat dissociation to produce H3O+ and HSO4-. So kita gunakan part of the acid kita iaitu H3O+ kita. Okay, H3O+ datang daripada dilute sulfuric acid dengan water. Okay, boleh tunjukkanlah. Boleh tunjukkan. Okey, ni memang nak tunjukkan macam mana kita dapat H3O+ dalam first step kita ni. Sebenarnya H3O+ come from the H2O and dilute sulfuric acid kat sini. Okey, so kita fokus pada H2SO4 dengan dilute sulfuric acid. Dah hilang dah dilute kat sini. Ada dilute kat sini, dilute. So sebenarnya masa SEM 1 dah belajar dah. Bila H2O dan juga H2SO4 bercampur, dia akan buat dissociation of acid. Betul tak? So H2SO4 acid. Dia akan donate a proton. Betul? Yang kita belajar Bronsted-Lowry definition tu. H2O act as base. So kita akan dapat HSO4 minus dan juga H3O+. Ni masa SEM 1 dah belajar ya. Di mana H2SO4 donate a proton. A proton that means H plus is donated. Base will accept a proton. That's why lah H2O akan form H3O+. So inilah datangnya H3O+ tersebut. So kita akan buat Lewis structure for the H3O+. H, O, H, H. So on oxygen ada one lone pair and get the positive charge on oxygen. Inilah H3O+ structure based on the dissociation of the dilute sulfuric acid in this reaction. Okay, itu datangnya kita punya H3O+. Alright class, so dah nampak dah how to produce the H3O+ in the first step for the mechanism. H3O+ in the first step come from the H2O and dilute sulfuric acid. Alright, so for the first step of the mechanism, same as the mechanism hydrohalogenation. Carbon-carbon double bond is the electron-rich site. Electron-rich site act as the nucleophile, will attack the electrophilic site in this H3O+. So antara HO dengan H yang banyak ni, so H is the electrophile sebab H is least electronegative compared to oxygen. That's why lah the arrow come from carbon-carbon double bond attack the H atom electrophilic site. Okay, iaitu electron diffusion. At the same time, the single bond between the H and oxygen breaking toward oxygen because oxygen is more electronegative atom. So kita dapat formation of the carbocation. So why the carbon number 2 positively charged? Because the H from the H3O+ is added to the first carbon. So what happened to the second carbon? Dia ada tinggal 3 sahaja ikatan around it. Ada 3 bondings remain around the carbon. So carbon tak cukup ikatan. Dia so dapat positively charged. And what happened to the H3O+? Dia akan membentuk H2O molecule. So the product form from the first step will continue in the second step. Kami dah cakap, mechanism ialah continuous process. So product form from the first step akan continue in the second step. What happened kali ni? Kali ni H2O act as the nucleophile while carbon plus carbocation act as electrophile. Kerana oksigen kali ni dah kaya elektron. Nampak tak ada lone pair elektron. So oksigen is the electron rich site act as the nucleophile. Manakala C plus carbon bercharge positif is the electron diffusion site which is act as electrophile. That's why lah the water molecule will attack the carbon plus to form a new single bond. So a new single bond is formed between the oxygen atom and the carbon plus. Why? Okay, sebab kita punya oxygen ni ada one of the lone pair is used to make a new single bond between O dengan C. So remaining lone pair on oxygen adalah satu sahaja. So oxygen akan dapat positive charge. The product form from the second step is called as the protonated alcohol. Okay, nama dia adalah protonated alcohol. So sama juga, the product form from the second step akan continue in the second step, which is dia akan eliminate of H+. Kenapa nak eliminate H+? Sebab nak bentuk alkohol. Kalau alkohol ada berapa H je? Ada satu H. OH. That means one of the hydrogen from the protonated alcohol here will eliminate in the third step. So kita akan gunakan the product form from the second step in the third step. Okay. Dia akan buat reaction dengan H2O sekali lagi. Macam yang sebelum ni topik 5.1. Kita buat mechanism for the halogenation using the Br2 in UV. Kami dia kata one drop of the Br2 molecule, one drop of the Br2 solution bukan dia bermaksud a molecule of Br2. Ada banyak molecule of Br2. Same concept with the water molecule. Okay, bukan satu je water molecule, ada banyak water molecule. So ni next water molecule, mungkin water molecule yang lain lah. Ada banyak kan. So the water molecule again will attack the one of the hydrogen from the protonated alcohol. So what happened? The single bond from the H and oxygen breaking towards the oxygen. Okay, ni pun sama juga konsep electronegativity. Oxygen is more electronegative. That's why lah the single bond breaking towards oxygen. Okay, so what happened? The oxygen remain only one hydrogen. Dah singkirkan satu hydrogen. So H2O dah attack H will form the H3O+. So H3O+ ni kita akan repeat the step yang nombor 1 balik. So dia akan keep repeating the step. That's why lah quantity of the acid as the catalyst tak perlu banyak pun dalam tindak balas kita. Tapi perlu ada untuk buat tindak balas. Sebab dia akan keep repeating. H3O+ akan gunakan semula untuk first step. Sampailah complete reaction occur, complete product form. Alright, itu pembentukan alcohol from the alkene by using the hydration process. So 3 step of mechanism. Sama, same as the hydrohalogenation. Pada pembentukan mechanism, student should consider rearrangement if the carbocation is unstable. Untuk kes ni, tiada carbocation rearrangement berlaku sebab dia dah form tertiary carbocation. So tertiary carbocation is the most stable carbocation. Dia takkan buat rearrangement lah. Tapi kalau dia terbentuk primary atau secondary, so you should check. Boleh ke tak boleh dia buat rearrangement tersebut. Okay? Alright, as example, write the mechanism of the acid catalyzed hydration of the 3,3-dimethyl 1-butene. So kena faham acid catalyzed hydration of 3,3-dimethyl 1-butene. So mula-mula awak kena draw the structure of 3,3-dimethyl 1-butene. Iaitu parent contain 4 carbon. At carbon number 1 contain carbon-carbon double bond. Carbon number 3 has 2 substituent of methyl group. 3,3-dimethyl. So 3,3-dimethyl attached to the carbon number 3. 1-butene. So complete the structure. Carbon number 1 contain only 2 hydrogen. Carbon number 2, 1 hydrogen. Carbon number 3 does not has any hydrogen atom attached to it. Carbon number 4, 3 hydrogen atom. So acid catalyzed hydration. What is mean by the hydration? Addition of water. So write the equation mesti ada tambah H2O. Acid catalyzed maksudnya mesti ada in the presence of the dilute sulfuric acid. Okay, so dapatlah produk dia. Boleh follow Markovnikov jugalah. Okay, ataupun can be written as, selain daripada cara tulisan macam ni, okay, ni Madam tak emphasize dalam tutorial. Dalam video Madam bagi tahu. So, kalau nak tulis acid catalyzed hydration of the 3,3-dimethyl 1-butene, boleh juga tulis plus H3O+. Dapat produk. Some of the question dia gunakan H3O+. Madam, H3O+ ni apa maksud dia? H3O+ ni adalah H2O in the presence of catalyst. H3O+ ni come from the H2O in the presence of the catalyst, iaitu dilute sulfuric acid. Bercampur dapat H3O+. Ataupun pelajar boleh juga tulis sebagai 1 butene tersebut, samalah reaktor yang sama, tambah dengan H2O, anak panah, H+. H+ ni maksudnya datang daripada dilute sulfuric acid. Ada 3 cara penulisan lah. Tak kisah mana-mana yang pelajar rasa selesa. Tapi bila soalan tanya, sepatutnya pelajar tahu. Which one referring to the hydration. Tiga-tiga ni adalah hydration reaction for the alkene compound. Okay, ini cara penulisan persamaan. So, how to show the mechanism for this reaction? Alright, so ni persamaan dia. So, madam dah cakap, kalau takut salah, write the equation first. Baru start with the mechanism for the reaction. So, kita cuba lukis kita punya first step. First step, we use the reactant. So, kita ada alkene, H2O dan juga sulfuric acid as the catalyst. So, in the first step, kita ada alkene kita, redraw. Lukis semula, react with the H2O and catalyst. Kami dah cakap dah, H2O with the catalyst, kalau dia buat dissociation based on the Bronsted-Lowry definition, will produce H3O+. So, you need to expand the structure for the H3O+. Mesti expand the structure of H3O+, which is the positively charged on the oxygen atom. Okay, yang ni awak dah belajar masa chapter 4, Lewis structure of the H3O+. So, you must expand the structure of the H3O+ to show the bond breaking for this compound. So, what happened in the first step? Kita ada carbon-carbon double bond, which is the electron-rich site, as the nucleophile attack the electrophilic site. So, in the H3O+ structure, each atom is the electrophilic site. Doesn't matter you nak attack the H kiri ke, H kanan ataupun H bawah. Tapi either one lah. So, the arrow should be from the carbon-carbon double bond attack the H atom. Okay, by using the heterolytic arrow, iaitu fully headed arrow. Kenapa? Sebab kita ada 2 elektron for the pi bond. So, the birth electron attack the H. What happened? At the same time, the single bond between the H and O will breaking towards oxygen because oxygen is more electronegative atom. So, you must show the arrow from the single bond towards oxygen. Okay, what is the product form? Okay, kita lukislah. Produk dia. CH2 become single bond CH, CH3, CH3, CH3 kekal. So, what happened to the carbon-carbon double bond here? Carbon-carbon double bond become carbon-carbon single bond and carbon number 1 and carbon number 2. Which carbon will added by the hydrogen from this acid? Based on the Markov-Nikov rule, iaitu H is added to the first carbon. That's why lah kita akan buat addition of the H to the first carbon. Kalau first carbon added by the hydrogen, so the second carbon, you check second carbon. Ada berapa bonding around it? 3 bonding around it. That's why lah carbon akan assign as the positively charged. Sebab tak cukup ikatan. Insufficient bonding, insufficient electron. So, this called as the carbocation. Okay. Dan check. The carbocation form is the secondary carbocation. Boleh? Dia membentuk secondary carbocation. So, what happened to the H3O+ tadi? Lepas dah remove H, single bond become lone pair on oxygen. So, kita akan lukis ada formation of product O, H kekal, lone pair on oxygen kekal. The single bond from the H and O akan form a new lone pair on oxygen. Boleh? Ni first step kita. Okay, sebelum go to the second step, proceed to the second step, check the carbocation form here. Secondary carbocation. Boleh tak dia buat rearrangement? to form more stable carbocation. So nak check konsep carbocation mesti macam hydrohalogenation. Mesti occurring at the neighboring carbon. So this carbocation ada carbon neighboring kiri and carbon neighboring on the right side. So carbon kiri awak ni primary carbon. So dia takkan buat lah. Sebab secondary dengan primary, secondary lagi stable. Tapi carbocation plus secondary neighboring carbon on the right side is quaternary carbon. Nampak tak ni? This carbon ada 1, 2, 3, 4. 4 carbon bonded to the third carbon. So, mungkin berlaku carbocation rearrangement to form the stable carbocation. Kita lukis dia. Okay, kita continue. Bukan second step, ni masih lagi first step. Tapi sebab nak buat rearrangement. Alright, so this structure is the structure from the first step. So maybe copy paste kat dekat slide yang ni from the previous slide. So before we proceed to the second step, secondary carbocation in this structure can undergoes rearrangement between the carbon number 2 and carbon number 3. Okay, so kita nak tunjukkan rearrangement for this structure. Okay, what happened? Okay, dalam topik mechanism of the hydrohalogenation, Madam just tunjuk 1,2 hydride shift. Betul tak? So, mungkin juga berlaku 1,2 methanide shift. Okay, how the methanide shift is occur? Cuba check the neighboring carbon on the right side here. Ada tak any hydrogen bonded to it? Tak ada. Semua CH3, CH3, CH3. So, dia takkan buat hydride shift lah. Dia akan buat CH3 shift. CH3 shift ni bergerak sekali dengan ikatan dia. So, kita panggil dia methanide shift, bukan methyl shift. Kalau cakap methyl shift salah. Dia methanide shift sebab CH3 shifted including the single bond. So, this carbon, carbon number 3 contain 3 methanide shift. Janganlah awak gerakkan ke semua methanide dia. Just one of the methanide group. Such as for this case, Madam nak gerakkan, okey, katakanlah Madam gerakkan the methanide yang bawah ni. Nak guna yang kat atas pun boleh. Yang kanan pun tak ada masalah. Sama je. Still lagi bonded to the third carbon. So what happen? You need to show the arrow for the shifted of the methanide. So CH3 group, including the single bond, shifted to the carbon number 2. At the same time, the positive charge shifted to the carbon number 3. So kita akan draw the formation of the tertiary carbocation. CH3 atas kekal, CH3 on the right side kekal. Okay, what happened? Carbon number 2 akan terima 1 methanide shift from the carbon number 3. At the same time, positively charged akan bergerak ke carbon number 3. Itu yang berlaku. Yang nampak Madam buat positive charge shifted to the carbon number 3. Methanide group. Methanide ni maksudnya CH3 include with the single bond. Shifted to the carbon kedua. So, after the shifted occur, it will form tertiary carbocation. Pembentukan tertiary carbocation. Nampak tak kat sini? So, maksudnya kita punya produk ada dua nanti. Iaitu produk come from the secondary carbocation and product come from the tertiary carbocation. Boleh? Okay, next kita akan proceed with the second step. Ini bukan second step, ni baru first step Saya nak continue with the second step. Second step maksudnya ada dua carbocation yang kita gunakan. Kedua-dua ni akan proceed in the second step because the birth of the carbocation is formed in the first step. Alright, so kita copy paste the product form from the second step to the third step. Okay, we have two protonated alcohol produced in the second step. So both protonated alcohol copy paste masuk dalam third step. So dua-dua ni akan menghasilkan dua produk yang berbeza lah. Okay, tu third step kita, the protonated alcohol akan undergoes reaction with the H2O. Same with the second step. H2O kena expand the structure. So in the third step, we need to eliminate one of the hydrogen from the protonated alcohol here. Tengok, O awak ni ada dua hydrogen. Alcohol supposedly how many hydrogen bonded to H? To O? One hydrogen bonded to O. That's why lah one of the H need to eliminate from this oxygen. Either one lah, tak kisah mana-mana antara dua ni. So contoh, okay, kita akan gunakan konsep nucleophile jugalah. Kita punya oxygen is the nucleophile, attack the electrophilic site, which is the hydrogen on the oxygen. So kita akan buat arrow kita from the lone pair electron on the oxygen, attack H. So at the same time, the single bond between the H and oxygen breaking towards oxygen. Because oxygen is the more electronegative atom, so by heterolytic cleavage. Ingat topik 5.2 semua gunakan fully headed arrow sebab dia heterolytic cleavage. So the product form CH3 for the first carbon remain unchanged, CH3 branching on carbon number 3, CH3 on the carbon number 4 remain unchanged, but the OH group akan dapat final product dia, di mana O awak remain only one hydrogen sahaja. Ni, dapat OH group bonded to the second carbon. Okay? So H dah eliminate, membentuk side product kita iaitu H3O+. Okay? H2O tadi, ni H2O awak, attack H, sudah akan dapat H3O+ semula. So this acid catalyze akan repeat the first step for the formation of the carbocation. Dia akan buat repetition step 1 sampailah ke 3 balik. Okey, itu untuk first protonated alcohol. Second protonated alcohol pun sama juga. Second protonated alcohol undergoes elimination of the H by using the water molecule. So water molecule act as the nucleophile, attack one of the hydrogen from the protonated alcohol. At the same time, the single bond between the O and H akan breaking towards oxygen. Tak nampak pula arrow dia kan. Dia tukar warna lain lah. Warna apa nak guna? Warna merah. Ni. The single bond between the H and oxygen breaking by heterolytic cleavage towards oxygen, because oxygen is more electronegative atom. So the product form CH3 for the first carbon kekal, CH3 for the second carbon remain, CH3, okay, remain unchanged, but on the third carbon, the OH protonated alcohol akan sebagai OH sahaja. One of the hydrogen dah eliminated from the O awak. So become OH group, which is the alcohol is produced. Bukan lagi protonated alcohol. Boleh So nampak tak? Produk kita OH added to the carbon number 3 and OH added to carbon number 2 pada second structure awak dengan pada third structure awak ni. So between these two product, which product is major product and minor product? Ni sama macam kita belajar sebelum ni lah. Kalau kita punya secondary carbocation less stable, dia akan form minor product. More stable carbocation, dia akan form major product. So based on this case, okay, which product is the minor product? Minor product kita adalah produk yang atas ni. Kenapa minor product yang atas? Sebab minor product di atas ni come from the secondary carbocation. Manakala yang bawah, second product is the major product because it come from the tertiary carbocation, which is more stable carbocation. Same as the previous mechanism. Okey, kalau pembentukan karbohidrat yang lagi stabil, dia akan bentuk major product dan seterusnya. So, dapatlah 2 produk. Dan jangan lupa H2O di sini dia dah attack H membentuk another H3O+ molecule. So, dapat juga H3O+, produk final dia. Okey, boleh? So, sebelum kita berakhir, okey, Media nak revise semula the question. 3,3-dimethyl 1-butene undergoes hydration with the catalyst. So, dapat produk. So, sebelum kita buat mechanism, pelajar mesti akan rasa one product is formed sahaja, betul? Each added to the first carbon or each added to the second carbon. Tapi bila buat mechanism, terdapat 2 produk. Nampak tak? First product awak each added to the first carbon or each added to the second carbon. So the name is 3,3-dimethyl 2-butanol. Ni. Di mana dia punya methyl group CH3 pada carbon ke-3 kekal, OH group pada carbon ke-2. So hydrogen added to the carbon number 1, minor product. So major product kita after we show the mechanism, terdapat produk dia adalah 2,3-dimethyl 2-butanol. Nampak tak? Dia punya asal 3,3-dimethyl. Tapi produk akhir dia 2,3-dimethyl. One of the methyl group dah buat rearrangement pada carbon ke-2 dan carbon ke-3. Dan OH awak ni dah ditambah pada carbon yang sini dah. Nampak tak? Tapi bila buat penamaan, masalah carbon kedua lah. Naming dia. Cuma ikutkan daripada asalnya, kita tak ada, kat sini tak ada carbon-carbon double bond. Tapi tertambah OH pada carbon-carbon double bond kat sini. Perasan tak? So that's why lah, pelajar kena tahu juga mekanisme ni. Sebab takut soalan keluar, kita tak nampak. Sebelum buat mekanisme ni, tak perasan pun, tak tahu pun this carbon are able to gain the OH group. Padahal sebenarnya dia boleh buat rearrangement one of the methyl group dia. CH3 shifted to the second carbon. Tu yang dapat 2,3-dimethyl 2-butanol, which is the major product yang awak memang tak boleh predict pun without mechanism. So pastikan pelajar faham risau-risau soalan mechanism keluar melibatkan produk yang kita tak boleh nak predict from the question. Awak kena tunjuk mechanism tu baru nampak major product dia. Dan major product lah yang penting untuk buat mechanism. Okay? That's all for the hydration. So, Media dah cover 1,2 hydride shift menggunakan contoh hydrohalogenation dan juga 1,2 methanide shift gunakan hydration. Sebenarnya, rearrangement ni dua-dua boleh berlaku. Mungkin juga hydration soalan periksa keluar 1,2 hydride shift. Hydrohalogenation dia keluar 1,3 methanide shift. Tapi konsep dia sama. Kita akan bergerakkan dia bila ada more stable carbocation is formed. Kalau tak ada pembentukan karbohidrat yang lebih stabil, tak perlu buat rearrangement. Itu sahaja.